Great. Okay, so hi everyone. Welcome to the software webinar hosted by Titan Robotics Club. We are grateful to have you all here, and today we are joined with Scott Gorlick, and he started his career in hardware and software QA, moved into product management, then software and security engineering. He believes in continuous learning and searching for truth, and he also advocates for customers' privacy and security through transparency. And I don't want to take too much time, so Mr. Gorlick, you can go ahead and share your screen.
All right, so let me just, don't use Zoom a whole lot, so forgive me if I get this wrong, but I think that should do. Everybody see a hello world? Cool.
Yep.
All right. So yeah, just a little bit about me. My name's Scott Gorlick. I'm a principal software engineer at Microsoft. But before we get into the whole bio thing, I wanted to start here because this is something I've been working on recently. Kind of ties into that continuous learning. And I know you guys are in your robotics club, so I know you build physical things, and there's also software. So this was something I did recently, which was basically from just breadboards, wire up a computer, and then make the computer say hello world. Not sure how many of you are, obviously all of you are interested in learning software to some degree. And the typical, hello world, it's just, console print line, right? This was a much more in-depth, how do you get from, electricity up into actual, words on a screen. So just kind of just very interesting little setup here. And there's some YouTube channels. Ben Eater is the guy who actually produced the kit and all this stuff. And he's a great, great teacher and somebody to learn from. So you got a timer circuit up top. And then actually, we'll do a little bit of Q&A. Can anybody guess what the components are? So where's the CPU? Can anybody find the CPU in this picture?
Is it the chip that's most central to the board? So the one that has no like WDC marking on it? That one, yeah.
Actually, no, that's the EEPROM. That's the instructions that will make the hello world print. But just to the left of that is the CPU. And as you can see, a lot of wires coming in and out of that, right? So you got the instructions here, they come into the CPU. Then down here at the bottom, this is the IO controller. So it controls, either this, this display here, or it also can control whether or not you're reading data in from the EEPROM or not. And then up top, there's a couple of different timer circuits. One of them is like a continuous timer where it just runs, and I can, change the speed with this little knob. But if you've ever, stepped through code, you go one step at a time. So it's always useful to have like a debugger, something to step through. So this button up here, gives you you toggle the switch and kind of hit the button. You can go step by step by step and see the characters print. Now each step, because this is assembly code. It's below C. So the assembly code, typing an H is actually probably about 20 instructions. So it's a little bit more complicated than just, system out print line, right? But at the end of the day, it's roughly the same. I thought this was interesting, and it should tie in nicely with, basically what you guys care about. And also just a good way to learn, find something that you're interested in and go with it. Let me go to the next slide. All right, so basic bio. I'm a principal software engineer. By the way, you guys asked some really good questions, made my presentation really easy. So basically, I just took your questions, kind of overlaying over my experience, makes a really easy presentation here. So what do I focus on at work? Primarily security and system architecture, system design, implementation, operations, and compliance. My schooling, I did really well in high school. I went to Cal Poly San Luis Obispo, got into a really exclusive program. It was materials engineering. Unfortunately, I wasn't able to finish. I completed about a quarter, and it just it did not work out for me. And this is kind of an important thing to think about, as you're growing up, as you're going and doing things. Not everything you do you're going to succeed at. So I was thinking, like, do I put a title page, and what would I put on that page if I wanted to, like, give myself a one-liner? And I'd have to say it's, fail well, learn how to fail. And that doesn't mean, go for failure. You should always go for success. But if you're going to do something, be prepared for it to not go well, right? Don't let a bad thing happen, learn from it. And then after I left school, I got married very young. Grew up, had a child, worked a lot, just random jobs. Ended up going back to junior college, getting an associate's in business administration, which, frankly, didn't really help me or hurt me, but it was really good knowledge to have. And, like, how did I get interested in software? It's just always been a tool I've used. The beard's a little bit gray. I started programming when I was 7 on an 8286 running DOS 3. There weren't colors on the screen. It was green or black, right? That was all we had. Another interesting thing about my bio is, the introduction started with hardware and software testing. But if we take a big step back, my first real job, I was a delivery driver for a Kentucky Fried Chicken. And in that job, I learned a lot about, like, obviously making chicken. But I basically ran the business for the restaurant manager. And so I learned a lot about doing business and just, like, how to treat the people that I worked with, how to learn from them, how to help train them, and then also just how to engage in community and, like, get people to, be interested in, basically buying our chicken. Like, why would you order chicken? So I'd go down to the businesses, I'd take them cards, whatever, and just kind of get things going. And basically, one of the most precious gifts I've ever gotten was a baby blanket from one of my customers back in those days. And so, you never know what job it is that's going to kind of, like, give you some direction in life. So never be afraid to take a job if you think you can learn something from it. That's kind of an important point. And then, from that job, I went through some training programs. I became, like, a restaurant training coach, and eventually, general manager of my own store. I was the assistant manager of one of the busiest Kentucky Fried Chickens in the world, and I actually made a lot of money, like a lot of money. I was young, but it was a lot of work, and it's not always fun working in a restaurant. But it's interesting, and it's not a bad job if that's what you like to do. So one of the, when I was a restaurant manager, one of the things that I did was I had to order food, and I had to order, paper cups and all these things. And so, how do you know how many cups you need? So how many did I have? How many did I use? When am I going to get more? Right. And then, you figure out I need 2 boxes of, medium-sized cups. And so, I produced an Excel sheet that I would just go around and take my inventory, and that would tell me what I needed to order. That same algorithm I actually used when I worked at a previous company to ship, like, toilet paper, register tape, and plastic bags to a very large retailer who happens to make the phones that you probably have in your pocket. So that same algorithm that was in my Excel sheet ships the the register tape to those retail stores. So you never really know what it is that that will be part of your next job or your next career step, or the thing that you're going to work with. And then, one of the other questions I was asked, how are you exposed to the field? So basically, starting at 7, my brother got a computer. We wrote software because there weren't a lot of games back then. You'd get a magazine, it would have code in it in BASIC, and you'd write the code and you'd play the game. So if I wanted to play a game, I'd write the game. That was the only way to play the game, or not only way, but that was a good way of playing a game. So scope of work, like what is it that I do today? Right now I'm working on an Azure resource provider, and I also built some internal tooling. Previous roles at at Microsoft, I've built some interesting things that some of which I can't talk about, but some of which are just amazing scale to think about. With a team of 3 people, I built a system that basically is in the stream of almost every alert that goes through Azure. And it's remarkable when you can find the right tools to solve a problem, how simple it can be. And it sounds huge, and it is, but really it was so small, and it was just a few of us, and we put it together and it worked. And so that's something to think about. Is you don't always have to build the most amazing solution. You have to build the right solution, right? So that's so the scope of work really. I use software to solve my problems. The scope of work really comes from whatever job I have at the time. When I was in e-commerce, there was fraud reduction. When I was in security, there was compliance evidence collection. Now I'm building a resource provider. It's more about resiliency and making sure things are resilient to disruption, right? Basic project types. This is probably a good buzzword bingo for you guys, stuff to look up. And kind of another important point here. I'm not speaking for Microsoft. My name is Scott. I am me. I happen to work at Microsoft. I do like the tools and the platforms that Microsoft provides, but I've also been a Java developer. I write C code. I just whatever language, whatever tools. That's what matters, right? Use the tools that you need to use to solve the problem that you have. So some of the project types. Currently, I'm working on, it's basically an ASP.NET web application. Lots of Azure functions. Some stuff that happens on VMs, virtual machines. Then I've also written like TypeScript and JavaScript web apps, some C and C++ code, and then lots of SQL and other data query languages, Java, enterprise applications. And then also, hardware and software, like some proprietary testing, both hardware and software. Real key point here is to not be married to your tools, but to understand how they work. Because whatever job you have, it will have very specific tools. If you're a bricklayer, you're going to use bricks and mortars. You're going to spread the mortar on the bricks, and you're going to put the next one on. There's a certain technique, and you better know it. If you don't know it, the wall is not going to stay up. What do I do day to day? Planning, reporting, communicating, designing, developing, and operating. So basically, at a principal level, it's a little bit different than like an entry level. Going early in career, there was much more just day-to-day developing or operating. So as you move up the stack in seniority or in experience, you start to see bigger patterns and you start to see bigger things. I'm sure, like as you grow up and you go through school, like you'll start to see some of the patterns that were being taught, like when you were learning addition and subtraction, when you get into calculus. Like it's like, okay, that these things kind of match this way. So being able to see those patterns, that just comes from experience and time. And so, as you spend more time in industry, working with the tools, working with the techniques, you will get better at being able to communicate, report, and plan. And then, tools, happen to use Microsoft Office, but, any Office suite, being able to use PowerPoint, let's say, or any sort of slideshow. This is an effective way of communicating ideas. I have visual, I have the ability to have notes over here. So, this is an important tool. VS Code, obviously, you've got to be able to write code. Visual Studio, Eclipse, or NetBeans, those are more fledged out IDEs that have been around for a while. And I also use like Ubuntu, and again, kind of the gray beardiness a little bit, working on a Linux or a Unix system and writing code in VI. That's actually how I learned how to write code, or well, text editor and BASIC back when I was young. But when I really got into code, it was mostly on Linux and then in VI. And then, you know, I use .NET, CLI, PowerShell, Bash, Azure, AWS, anything. Any tool that will help me solve my problems is a tool that's on the table to use. Doesn't really matter who makes it. What matters is, you know, how it helps you solve the problem. You know, some specialized tools that I've used in the past. So offensive security tools like hash cracking software or other things like that to figure out if something is vulnerable. Tenable Nessus, which is like a vulnerability scanner. That's more for defensive security. Trend Micro Deep Security is an IDS IPS, you know, so intrusion detection and prevention system. Hyper-V and VMware, those are, you know, basically the hypervisor layer where your VMs live just above that. So being able to manage machines on big servers, you know, so those are useful skills or specialized tools. And then hardware-wise, again, kind of going in the experience into my past, I worked at a network and system management system, and so we dealt a lot with like storage arrays and other internet gear. It's like Juniper, Cisco, and Extreme networking hardware, and then Hammer call generators. That was always a lot of fun to do the set up environments that looked like, you know, T-Mobile's, you know, network core. And then you guys asked a very good question about like how have I learned to do this outside of university? And I think it's really important to not make software the goal. The goal is the thing that you love, that you're passionate about. Software is the tool. So the more that you care about the thing, the better you will use the tool for it. And, you know, if your goal is to just write the most elegant loop, that could be the goal, right? I want to write the most elegant sort. Fantastic, do that, right? But at the end of the day, there's, you know, you're building a robot. I want to make this thing turn the most efficiently, right? I don't want to have to do the trigonometry calculations on the fly. Oh, make a trig table, you know, something like that. So basically the solution or the software, it's just the tool. I put a couple of links or, you know, domain names really up here. So Project Euler, Euler was a mathematician. That's a good place to go to learn just very low level math, like write Fibonacci in C. You know, what's the 10th element in Fibonacci? You know, also, and you know, what's, yeah. And then Leak Code, it's another good place to go. Also very good. The software industry will use that as not exactly your interview questions, but the interview questions that you'll be doing, a lot of them will show up on Leak Code. So it's not, I don't say that in a way to kind of, hey, study for this exact interview. What I mean by that is, you know, sitting and looking at those puzzles and thinking about them will help you solve them on the fly. When I interview people, one of the hardest things I have to do is, how do I get the way you think about problems when I only have half an hour to talk to you or 45 minutes, right? So there's a lot I need to learn in 45 minutes. And so having like a structured problem, and if you're a good candidate, you can look at the problem and break it down. And then, you know, when you're working with somebody through that interview process, you have to kind of like give them a little hint here and there. So if you're interviewing, you also have to be able to take a hint. So, you know, that's kind of a later question you guys asked. So STEM advice, this is hard. So the world's changed a lot, and, you know, STEM has become much more prevalent than it was when I was young, as a goal for a career. And so there's a lot more competition. And so like, as I was remarking about, go to lead code, study for interviews, things like that, practice, solve puzzles, those things will help you think about problems and will help you solve them regardless of, whether you're working in a restaurant or if you're working at, a big 5 tech company. Just being able to problem solve is a very important skill. Internships and volunteering, those are also, like, an internship is a great way to get your foot in the door. And then, volunteering is also, I'm passionate about volunteering because you get to do a thing, hopefully you get to do a thing that you love, as well as help someone who might need it. And it's also like, you're young, you don't have a resume that's, got 10 years of experience, but you can put that on your resume, and people will see that, and they will ask you about it, and it will give you experiences that you can share. And the experiences that you get volunteering, they are valuable because you've interacted with other people and you've done something useful. So job hunting, definitely internships are probably that's probably the easiest thing to do, because basically you go out and they're looking for people to come and talk to them. And so you talk to them, if you get in the door, you start to meet people, and then you build a network, and then you can potentially, just kind of get an in on a job through that way. Industry specific skills. So depending on the industry that you're, thinking about, like, you should know what the industry cares about, and you should also know what are the high order skills in the industry. I put a star there because knowledge is not the goal, but having the knowledge will get you in the door, right? So if you're looking at the automobile industry, know some stuff about cars, right? It will be useful. And then why Microsoft? I actually thought about this a lot, and I don't think that any company is perfect. And I don't think that any company is, like, frankly, very good. I think everybody has to make decisions, and you can always find a fault. When I look at Microsoft, the faults that we make, we fail well. Microsoft did not have a great reputation in security through the 90s. Some of you may know that's something else that was kind of asked, and I'll get into that later. But irrespective of, like, past missteps, now, like, Microsoft is invested in security. They've really upped the game on the security development lifecycle. And frankly, like, the tools that I get to use and don't have to think about, they empower me to do more. And that's Microsoft's mission statement, is empowering every person on the planet to do more. Paraphrased a little bit, but that resonates with me. Another important aspect, like a couple of years ago, the Xbox commercial for the Super Bowl for the adaptive controller, like, it was such a beautiful message that they're saying, when we play together, we win. And I think that really is true about how Microsoft tries to solve problems. All right, let's see, I think there was something else. Yeah, right. So basically, and kind of going back, I really want to focus on this. Industry specific skills, like, it's a good way to get a job, but keep learning. All right. So, how did you learn was the question that was asked, but really it's how do I learn? I try, I do, I fail, and I try again. So let's see, what's something I've learned recently? The breadboard computer. That was something that I looked at and I thought, I'm working in the silicon industry building, tools to help people build chips. I should probably understand what's happening. And so, having that need, it's not really a job requirement, but it is kind of part of my job. It's at least tangential to it. Having that thing to look at and say, oh, that's something I should know. So I looked at it and I said, okay, let me do that. So I started putting it together, and it felt nice to do, and it was fun to do, and I can kind of get going with it. So now I'm making the video card for it, right? So you just kind of keep doing it, keep trying something different. And really, really helps when it's something you care about. Was it difficult to get started? Oh my, absolutely. It took quite a lot of convincing from my friends to apply for a tech job. There was a perception on my part that to get into tech, you had to have the college degree. It had to be this, you have to be that, you have to be, able to do all these things. And frankly, that wasn't the case, for me at least, and at the time. And so a friend of mine happened to know somebody else, and this is how I got into the hardware testing, and they needed somebody pretty quick. And so basically, just based on a situation and a friendship, and obviously, yes, I did have the skills. I did end up doing the job, and I actually did very well at it. It was just a situation, and I seized the moment. But was it difficult to get started? Terribly. And it was me in the way, mostly. And then, has it become easier as I progressed, or the opposite? Yes. There are some things that are much easier. There are some things that are much harder. There are things I've had to do that are like physically, like I've worked on a security incident where I was on the phone for 120 hours, basically. And there was a lot of work happening, like literally just like taking a 2-hour nap and coming back. And I've worked some of the biggest, like basically every significant security event that's happened in the last 5 years, I've been part of, more or less. And so like those things are hard, but they're also rewarding. Because I don't know what to say there. That's the stakes are higher, but it's a lot of the same things, just bigger. So I wouldn't say it's gotten really harder or easier. It's just different. And then what's my opinion on Linux from a security standpoint? It's just as bad as anything else, or it's just as good as anything else. Windows is just as bad or just as good as anything else. There's dimensions to all these questions. And you've also left off BSD and Unix and Solaris and, lots of other operating systems. So, and then we could even get into the distribution wars and think, oh, is it Fedora or is it Debian based? I think Linux is an important tool. I think BSD is an important tool. I think Windows is an important tool. They all do different things. With respect to security, anything will be as good as you treat it. If you keep your system up to date, you'll be better off. If you follow best practices, you'll be better off. And that is something that is a differentiator between Linux and Windows. How to put this? If I have a Cisco firewall and I just plug it in, no packets get through. It fails closed, right? So failing closed means without a configuration, it's closed. If you want to open something up, you have to open up that port, right? And so that mindset is, I think, a a strong differentiator between, not strong, but it's a differentiator between the Linux and the Windows approach. Windows is more open, meaning accessible, usable, but also, that does introduce risk. Linux is more closed, that introduces complexity, right? So as you increase complexity, you can also increase security risk because people will make a poor decision because they don't understand the consequences of the decision. But Windows, the other side, I didn't touch anything and it fails open in some cases. That might not be as good. It's kind of going back. You'll hear a theme here. What's the tool? What's the job, right? Do I work on Defender? No. Other form of security? Yes. I'd say every software engineer should be working on some form of security. And if you're not, you're part of the problem. So with respect to code security, like that's just, I live and breathe that. Trying to write tools that make sure it's easy to do the good thing and hard to do the bad thing or an unintentional accident. I don't think anybody really intentionally makes a security vulnerability. I didn't think about that. I had my blinders on. I didn't ask other people for input. In the past, like I said, I've worked on security automations. One of the biggest thing I did, and I'm actually really proud of this, if somebody sends you an email and that email is a phishing email, and the website that's phishing you is hosted on Azure, and so somebody sends you an email, you're an Outlook customer or a live.com customer. We detect that it's phishing. That resource is on Azure. It's not necessarily a paid resource. That resource gets deleted in like 15 minutes. And it's all per our policy. And it protects our customers without harming our other customers, right? Because, as Microsoft, we have customers on both sides, like people producing systems and people consuming them. And so we have to both defend the consumers and the producers. So that was a big thing. That was a lot of fun, actually, and a lot of really good exposure on that. I ended up having to talk to the CEOs of some pretty big companies about that. Like I was sitting at work at my desk and somebody comes in, hey, can you come talk to these people? It's like, sure. And I'm wearing jeans and a t-shirt. And they dragged me into a room and there's like Bill and Melinda Gates, CEO of T-Mobile, Starbucks, the head of the NIH in England. Oh, they gave me a hard time because they actually had a big issue with phishing and they were not happy with us. So, that was interesting conversations. So that's kind of going back to the why Microsoft, you get to fight big dragons. There's no sense in fighting a little dragon. And what programming languages do I tend to use? Of anything, mostly C#. C# is really flexible. I enjoy it. You can go low level. You can stay abstract. It's flexible. That's where I spend most of my time these days. And then university, I went to Cal Poly Slow, but didn't finish. All right. Oh, I think I about hit the mark at 40 minutes. That's all I have to present. And I think I answered some of your questions, but I would love to hear if there's more you want to hear on a topic.
All right, I guess we'll get into the Q&A part of the webinar now. Okay, so we have some questions already prepared. If anyone has any more questions, feel free to type it in chat and we'll ask those too. To start off, you talked a bit about how you did not have a computer science college degree and largely taught yourself programming, and how it took a lot of convincing from your friends to get a job in the tech field. Could you elaborate a bit on your path to where you are today?
Sure. So going way back, oh, is my video now? Okay, let me, because I'm sorry, I thought I had my video on. So going in the way back, like I said, 7 years old, got a computer, you get the magazine, you type the code, you see that things happen, it means something, you go back to playing on your bikes or whatever, and then you come back in a little while later and you do some more of that. So just basically being in that environment was very helpful. I have brothers who are 4 and 6 years older than me, and it's funny, we're actually all in software. My brother is a VP at a home banking company now. My other brother works at a financial services company, and I'm working here. So you can see a theme, like the reason that we all ended up in software is because we all grew up together. We all it's just the thing we did, right? So I don't know how you could teach that, but I know how you could learn that, and it kind of goes back to what I was saying about do what you love. Frankly, I really did actually enjoy being with my brothers and playing games and doing stuff like that. So like that's as much of the memory as writing the code, right? And in business, or sorry, at work, like I think people remember me more for how I work with them than what it is that I do. And I'm sure if you've worked on a group project with people, like it's important for you to it's important for you to be able to how to say, like when you make an impact on somebody, you're not going to make an impact on them like, look, this is the best way to multiply 2 numbers, right? But the way you make them feel about the things that they do with you, that's what they'll remember. And frankly, like that's something else that will help you grow, because like, or not necessarily you, but the person, like if you make people feel good, they will grow more. And so like at the principal level for me, like one of my core responsibilities is mentorship, right? So I'm here talking with you guys because, frankly, I love doing this. I'm very passionate about what I do. I think it's, there's a lot of opportunity for people to learn more and to be able to do more if they don't have to like toil away and like do all the things by hand, write some automations, makes, you guys are into robotics. Thank you. You're helping. Let's see. And then, like with respect to like how more learning on, like even on top of that, find somebody on YouTube who's, like I watch 3 Blue 1 Brown, Eater.net, PBS Space Time, like basically just study, and just don't ever stop learning. That's kind of an important thing. I've got this book, right? This is a college textbook. So you don't have to be in college to have a textbook.
All right. So we have a question in the chat. How do you approach problems at your work? You talked a little bit about that when you're talking about what you do day to day. A little.
Sure. Every problem breaks down into just really only a handful of real problems. What do I need to know to make the decision? And if you can break those things down and down and down and down, you get a very, very clear sequence of operations that will help you solve that problem. If you're thinking about a puzzle, right? Like, you've got a Rubik's Cube, right? How do you solve a Rubik's Cube? There's a couple of different ways of doing it. The way I do it, I can remember how to do it. It's not the most optimal way, but I remember it, right? And so I'm less concerned about the optimal solution for that. But I'm still trying to learn how to do the cosine algorithm and get it down to the 15 moves max. But I'll never get there. I don't remember that way. so that like, know how you think, know how you remember, and that will help you solve your problems.
Okay. You talked a bit about how you worked on Azure and like warning systems and stuff with a small team, and how you can't mention all your projects. What is your favorite project that you worked on?
Oh gosh. The one I'm most proud of is CDoc Insights, which is that tool that that I cited, because it was a team of I was the only software engineer on the team. there were it was me and 5 other security engineers. Nobody in their title had software engineer. I wasn't even a software engineer. I was a security engineer at the time, which, like I said, software is the tool. The job happens to have a different title. But so my peer Miguel, he always would tell me, I'm not a dev, I'm not a dev, I'm not a dev. And I'm like, you're writing good code, shut up. You are a dev, right? Like, don't sell yourself short. And, to that point, like, that's why that's the most impactful thing that I've done, right? Because not only was it a big, like, it was a small system and nobody in the world except, maybe 50, 60 people will ever see it. But, like getting Miguel left his role as a security engineer and is now a software engineer in the engineering team, in MSRC now. So like, I helped somebody make a move in a career to get to a place that they didn't think they could go. And that, like, like I was saying earlier, it's people remember you for how you treat them and how you make them feel. Like that's now what has become important to me. Early in the career, it was very important to write the best loop, but I'd find myself alone a lot and alone at work. Like, people would not necessarily want to work with me, and that doesn't feel good. Not and like, work isn't like a social. It is a social thing, but it's not like where you get your friends. But you should feel good. You do it a lot. Like when you're at work, I mean, you're going to spend 40 hours a week there. You should be with people you like, and you should be with people you feel good with.
Does that kind of tie into how you stay very motivated?
Yeah, absolutely. And it also kind of goes back to like, why Microsoft. I have a student that I taught, because I taught high school computer science for the TEALS program, which is Microsoft's initiative to try and get like computer science education in high school. There's code.org, and then like Girls Who Code. There's a number of different initiatives that are all pushing for that, and I support them all. They're great. Anything that can teach someone a new tool is great. So Arun is now working at GM. So somebody I taught high school is now working at General Motors, and he wants to go into their autonomous car division, right? So that's pretty cool. Yeah, definitely seeing people grow is a great motivator.
All right, that's really cool. Earlier you talked about C++ and how you like it for being so versatile. Is that your favorite programming language?
C# actually is what I was saying there. C++ is great. The motto of C++ is it's your foot, because you can do anything you want in C++. There's no boundaries. Frankly, though, that's where a lot of security vulnerabilities come from. C# provides some type safety, which protects you against those things. C# in its nature is not necessarily secure. Neither is Rust or C or any of the other languages. But C++, it's easier to step on the landmine. C# makes it a little harder. You have to actively step on the landmine. You're like, yeah, that's a landmine I'd like to step on. And then Rust is a good low-level language for having type-safe code, but still be low-level. And JavaScript is ubiquitous in the browser. And if you're good at kind of going back and forth server-side and client-side, that's important.
Sorry about that. Must have gotten the two C's mixed up.
Yeah, it's okay. Well, what's funny is so CSharp, so there's C, and then if you increment a number in C, it's use and then increment is C++, right? So you go from C to C++, and then to go from C++ to CSharp, it's C++, plus. And if you put the pluses together, they make that hash sign, right? So it's C, C++, C#, right? It's just the iteration.
That's pretty nice. So you're talking about how you really liked those secure programming language, along with a couple others like.
Yeah. Isn't C# based off of Java though? No, C# is actually, it's got its own spec. It's ECMA, ECMA, I forget what number it is, but it's got an ECMA specification. It's actually based on C++. It takes patterns from Java. ASP.NET MVC actually takes patterns from Java Server Faces, which was one of the first MVC frameworks back in like a long time ago. So yeah, there's a lot of interplay between the two. And then principles that kind of share, like generics, they're common on both sides. But C# and Java are fundamentally different in how the systems get built. I should like the reason I actually kind of wanted to get out of Java was more based on like who was maintaining the libraries than like what they were doing, or how good they were, or any goodness, because everything sucks. There's nothing that's good. Like, everything has some compromise to it. So you always have to look at like what's the failure that you want to have, right?
Okay. What do you think are the most useful programming languages to learn?
The one that gets you the job. The next one you need to know. These are all the easy answers. Let's see. I think more important than the language that you need to learn, understanding what it is that you're actually doing with the language is important. Yes, I can solve the Rubik's Cube. No, I have a 7x7 in the other room if you want to wait a little while. But let's see. So I distracted myself. I'm sorry. So most important programming language to use. Learn. It really does come down to what industry do you want to be in and what language do they use. If you want to work in financial services, you should probably know some Java, right? You should also know C, right? If you want to work in security, you probably want to know Python, right? If you want to, like, I like to do offensive security stuff, and so when you do that, you need to be able to speak in different languages, because depends on what target you're attacking. And so if I'm attacking a Linux host, I'm going to use Bash, right, or Python or something like that. If I'm attacking Windows, I'll use PowerShell, right, or something else. So having that flexibility is useful. So maybe the answer, what's the best one to learn, is the one that you don't yet know. Where do you start? Now that's a good question. If you were to start at a language, I would say something that is high enough level that you're not dealing with pointers. Like, so don't learn C++ first. Get some logic down and then go into the C++.
Okay, that's really insightful. All right. So when you were a kid, you talked about like how the computer science and STEM field looked really different from what it is now. What do you think it'll look like in the future?
If you look at manufacturing jobs in the United States, going 60s and 70s, you could come out of high school and go straight into a factory job and feed your family and take care of your family. World's changing, and I'm not going to get too terribly political, but if you watch the manufacturing job changes, that's kind of the lead for what happens in services jobs, right? And so America's economy has shifted more to services than manufacturing. And so if you look at the manufacturing jobs, you now must know like algebra 2 trig in order to operate any of the machines in a factory, basically, because you have to be able, like, you guys know robotics, sine, cosine, tangent, right? Like these things come up all the time. You're thinking I need to move 15 degrees that way, right? Well, how much do I move? So, upskilling the factory workers, it kind of ties into like what does the tech jobs look like in the future? I think you've got it backwards. Tech jobs will be the only jobs, only air quotes only. If you're working in a bank, you're going to be writing code. If you're going to be working in a publisher, you're going to be writing code to some degree.
Okay. Any tips for high schoolers looking into STEM?
Just keep practicing. Find the thing you love and keep doing it. Don't ever stop. Find a way to apply your passion and keep doing it.
All right. Earlier, you were talking about how it took a lot of convincing from your friends to go into a tech job. How was it that you first found your first tech job?
Yeah, so my friend John was like, this guy Chris needs somebody, and he needs him now. So you could probably get that job. And I went and I applied and worked there for about 8 months, and then the company we all got laid off. Parent company kind of sold off that division. And so like the next job that I found was like, oh crap, I need a job, right? So it was very much just like, now I have to keep feeding the family. And so I went into network management. And actually, it was pretty fortuitous, like the transition from working in the hardware and test. I keep beating a drum that software is the tool and the job is just what you use the tool for. The same stuff I was doing at the hardware test company, I ended up applying when I worked in network management, right? Because it's networking is really, that was the common thread. And so there was some knowledge that I had. And then I had to learn a new language. I went from, the tooling languages to like Java and then ultimately CSharp. So like yes, how do you learn these things as well? Because I had to. There wasn't really a choice. It was either like go find a new job or learn this thing. So, that's not necessarily the best way to learn something. If you can optionally and opt into learning a thing, you'll probably do better. But having to do a thing, it kind of helps.
All right, I think we have one last question. Do you have any issues dealing with other people when you're working?
Yeah. Isaac, that's a great question. And I'm really glad to end on this one. Wow. They didn't do it on purpose. Empathy. In the past, I may have been a little bit curt with looking at someone's code and thinking, what were you thinking, right? But now that I'm a little bit grayer in the beard, like if you looked at some of my code, you'd be like, what the heck what were you thinking? It's like, well, it wasn't my choice. We had to ship, right? Wow, that's a really good question. You guys are great at asking questions. And do I ever have issues dealing with other people? All the time, all the time. I'm not a people person. I enjoy interacting with people and I enjoy watching people grow. I have a very hard time like interpersonal relationships. Like it's just, I might be a bit on the spectrum. I actually don't know. I've had people ask me, which kind of implies I might be. So I don't know. But it's important to remember that we're all humans in our skin and there's a human on the other side of that code. And you have to talk to the human. And they didn't mean to hurt you. They just made some code. That might be a good way of looking at it.
Yeah, I think that was like the best way to answer it. Any last words of wisdom before we wrap up?
Listen to everyone. Hear everything. The broader perspective you have, the better you'll do.
All right, cool. I'll leave closing off to you, Kira.
Yep, thank you. Okay, and that is it for today's software webinar hosted by Titan Robotics Club with Scott Gorlick. And we hope you were able to learn more or get inspired because I know I was very inspired. And thank you. And if you want to rewatch this webinar, be sure to check out our YouTube channel at Titan Robotics Club. I put that in the chat. And I will put our Instagram next at IS Titan Robotics for future news or updates on our club. And yeah, thank you for coming. And thank you, Mr. Gorlick.
Thank you for having me. I appreciate the opportunity.
All right, thank you.
Thank you, everyone.
Take care.